Number 4 says that GRE scores for graduate school are approximately normal with a mean of 544 and a standard deviation of 103. So the GRE is kind of, you take the SAT or the ACT to try to get into college. So if you want to get your master's degree, if after the 4 years, you take the GRE, that's a way to try to get into graduate school. So basically test scores. And so they tell us that there's an average of mean of 544. So we'll do, we've got a mean of 544, and then we've got a standard deviation of 103. And then so the question is saying what percent of scores are higher than 600? Well, let's take our curve here, for instance. And if I took my curve, what we're saying is that the average, so here's our average, is 544, and then one standard deviation out, so if we add 103 to that, so we're at 647. And what the question is asking is that what percent are higher than 600? So here's 600 in between, and so we're saying what percentage does this represent? Well, you know that half of the curve is 50%. That's not quite 50%. 50% would be 544 and up, but we want to know 600. So I don't know, maybe 40%, 30%. That's what we're trying to figure out. So let's first of all figure out. We got to find our z-score, right? Because that tells us the percent that a certain piece of the curve represents. So the score that we're looking for. So we get our z-score here. The score we're talking about is 600. The average is 544. And then the standard deviation is 103. So if we crunch the numbers on that, let's just throw that in the calculator. So we got 600 minus, not 6,000, 600 minus 544. And then we're going to divide that by 103, and we get 54%. I'm sorry, 0.54, right? Remember, this actually is not our percentage yet. This is just our z-score. 0.54 actually should make sense because, again, we're saying that it's in between the average and one standard deviation. So let's call it 0.54. Again, though, that is not 54%, right? That's our z-score that we then need to go to our table and figure out what 0.54 matches up with. So there's our 0.5, and if we go over to 4, we see that it matches up with 0.7054. 0.7054, which is approximately, if we move it over 2 decimal places, let's call it 71%. We'll just round there. Okay, so 71% of people got higher than 600. Well, that's not quite what that represents, right? Because we're talking about the z-score gives us the area to the left. So what that tells us is that 71% of people scored less than 600. So if we wanted to know what percent of people scored greater than 600, well, it'd be the difference. So 100 minus 71, right? That gives us 29%. Right? So we could say that 29% of people scored, and let's just do a quick write-up here. 29% of people scored higher than 600. All right, so let's look at the other question. The other question says, what score would you need to get in the top 10%? Well, let's see, 29%, so a 600 would get you in the top 29%. So we're thinking that you'd have to get something higher than a 600 to get into the top 10%. So how we'd figure this one out, and this one's pretty much the same, there's kind of one extra little twist on this, is that what we're looking for is we're looking for the top 10%. So I'm just going to kind of estimate on my curve here, but let's say that this represents that little section right there. Actually, I want to kind of clean that up a little bit, because again, by highlighting that much, it makes it seem like it's a big section when in fact, this makes my highlighter's too big here, when in fact it's actually it's a tiny, tiny little sliver there. So we don't want to make that section seem bigger than what it is. So what we're trying to say there is that if you have an average of, we said the average was 544, and we want to be in the top 10%, so here's our average, what score do we need to get, right? So what we're saying is that what score, so that right there, what score does that need to be so that we're in the top 10%? Well, what I don't know is that I want to know, is this one standard deviation out? Is it two standard deviations? So what I don't know is I don't know what the z-score for this would be. So if this represents 10%, right, I want to be in the top 10%. That means that I'm better, or score higher, that we score higher than 90% of the people, right? So if that little section, let's just label this, if this little section is 10%, then this bigger section represents 90%. So what I'm finding is I need to find what's the z-score for something that represents 90%. So let's go back to our table. Now on this one, what I'm representing, or I'm trying to figure out, is that where's 90% at on this thing? Is it one standard deviation away, two standard deviations? You see, one standard deviation is 84%, two standard deviations is 97%. So I need to look somewhere in here. I get 0.89, 0.9032. That seems like that's going to be as close as I'm going to be able to get. So let's call it there. That's a z-score of 1.3. So what I'm saying is that if the z-score is 1.3, that it translates to roughly 90%. Okay, so that's what I'm looking for. Is I'm trying to figure out what that score is going to be. So what score is better than the 90%? So this one's a little bit different. I actually, instead of solving for my z-score, I actually know what my z-score is. So instead of z, I'm going to write what my estimate for it is, which is 1.3. And then x, that's what I'm looking for. This is my x right there. I'm trying to figure out what score I need. The average, we know what the average is. It's 544. And then our standard deviation, we know what that is. It's 103. So what I'm trying to do is I'm trying to solve this equation for x. Anytime you have a fraction, right, because we've got a fraction over there on the right side. Anytime you have a fraction, you don't want something to be a fraction, you multiply by the denominator. This is our fraction buster. If you multiply by exactly what's down there, it ends up canceling those two things out, and then you no longer have a fraction. But what we do to one side, we have to do to the other side. So let's multiply 103 times 1.3, and we get 133.9. So we've got 133.9. Fraction goes away, so we got x minus 544. And then I'm just solving for x. So I'm going to add 544 to both sides. Okay, let's add that up. So 133.9 plus 544, and I get 677. Let's just round it to 678. So x is approximately 678. So what that means is that I would have to get at least, we said that it was going to be more than a 600, because a 600 just got you in the top 29%. So we said that it was going to be more than 600. The exact number there is actually 678. That would get us in the top 10%, right? So a score of 678 puts us in the top 10%. Right? And because we're saying, maybe if you know that was a goal, right? Because certain universities, maybe give you a scholarship or admittance if you're in the top 10% or something like that. So if we were trying to figure out what our score was to create a goal, that's what we would do there. All right, so go ahead and stop here and try number 4 on the right side.